To graph a polynomial that's already in factored form, the first thing you should do is make a sign chart. So for this one, the sign chart looks like this, with a plus here, a minus here, those are the zeros, but another minus here because we have the even exponent, and then a plus. So now, to translate to our graph, the zeros happen at -2, 1, and 5. And for the graph, the plus means that it's above the axis. The minus means it's below the graph. And here, notice how it goes from minus to 0 and back to minus. So it kind of makes like a W. And then finally, this plus goes like that. So it makes a W-shaped thing. So when you see an even exponent, you have double root, which means that it's like sort of touches the x-axis, tangent to the x-axis. The next type of graphs we'll look at are graphs of the form y equals a over x minus h plus k. Simplest of them is y equals 1 over x. If you multiply both sides by x, you get xy equals 1. xy equals 1 has, for instance, 1, 1 as one of the ordered pairs. But as x gets bigger, like 10, you would need 1/10 for y to make it a product of 1. And when x is close to 0, like 1/10, y would have to be 10. And you end up getting this shape where we have a vertical and a horizontal asymptote. We saw asymptotes during the unit on tangent graphs and cotangent and secant and cosecant, but here they are again. Now, x and y could be -1 also, and we end up with this other branch, and those two branches are part of what's called a hyperbola, and that hyperbola has a center, which is at 0, 0. If there's an h here, it changes the vertical asymptote, because now this thing's undefined at -2, so we get this vertical asymptote. Horizontal asymptote is still at 0 if there's a constant in the numerator. And we end up with something that looks like that. It's a shifted hyperbola. One thing to notice is that these 2 points, which are officially called the vertices of the hyperbola, they are kind of 1 unit to the right and 1 unit up from the center, and the other one is 1 unit to the left and 1 unit down. When we have a k value, it shifts the whole curve up so that the horizontal asymptote is no longer on the x-axis. So the whole curve shifts up, so it ends up looking something like this. This sort of center point is 0, 3 now, which makes these vertices, you kind of go 1 to the right and 1 up, when there's 1 here at least, 1, 4. Sometimes they ask you for that. And this one is -1, 2. Not drawn that well to scale. When the numerator is not 1, but in this case it's 9, this is kind of like xy equals 9. So it no longer has 1, 1 as one of its points, but it has 3, 3. It still looks like, still has the same asymptotes, and it still looks like this hyperbola. But the difference is the center is now 3 units. To go from the center to the vertices, you go 3 right and 3 up, or 3 left and 3 down. Pretty much the square root of 9 tells you how much to go right and up or left and down. When you have a negative sign in front of this, what that does is it flips it upside down. And now the branches are like this. So we're sort of in quadrants 2 and 4, at least with respect to the asymptotes. Here I've got an A, an H, and a K. So the -2 tells me that the vertical asymptote is at 2. The +3 tells me that the horizontal asymptote is at 3. The fact that the 4 is positive means I'm in sort of this top right and bottom left. And the fact that it's 4 instead of 1 means I go, well, if this center point is 2, 3, I go 2 to the right and 2 up to get to 4, 5. And the other vertex is 2 to the left and 2 down, which is 0, 1. And then we connect. Now this looks more difficult. It does not have, like all the others, had some kind of constant in the numerator, and this doesn't look like that. However, we can pretty quickly turn it into that other form. So we get 2, that's 2x plus 2, remainder 3. We're going to write that 3 as 3 over x plus 1, or I'll write this as 3 over x plus 1 plus 2. I hope you don't mind. I'm going to change this to a 6, so that's a 6, so that's a 4. I like when this number is a perfect square. Okay, but after you do that division, it turns into the form we're familiar with, and we graph it: horizontal asymptote at -1, vertical asymptote at +2. The 4 means I go up 2 and right 2 to get to the first vertex, and down 2, left 2 to get to the other one.